All right, everyone, this is page 378. We're going to apply the theorems that we've been talking about that we know that will determine each measure. So in 4a, where we say determine the measure of arc RT, right? One thing that we need to do right now probably is highlight arc RT just so we can spot it where it's actually supposed to be there. And then in this problem, we're going to identify what we do know. We know right now that FG, this arc is 86 degrees, and then this arc down here is 21 degrees. So in order for us to identify the measure of arc RT, we're first of all going to have to use the fact that this angle here, right here, is supposed to be half of the intercepted arc that it's on. So it's half of 86. This is the measure of angle W is 86 divided by 2. Which, checking for a minute, 86 divided by 2 is 43. Okay, so since this angle is 43 degrees, okay, that's because in the outside circle, angle W is inscribed in the outside circle, so we're using the inscribed angle theorem. Now, the angles here on these circles, now angle W is on the exterior, and by the exterior angle theorem, the measure of angle W is half of the difference of RT minus HP. So we went from using an inscribed angle for the big circle to an exterior angle theorem, and that means that we are looking at 43 degrees. Angle W still is 43, but it's going to be half of what we're trying to find, the arc degree of RT, minus 21 degrees. Multiplying by 2 will allow us to cancel the fraction. So we're back up to 86, and multiply by 2, equals the measure of RT minus 21. If I add 21 to both sides, by adding 21 here and adding 21 here, I'm isolating the measure of RT, and then I just have to do the simplification. 6 plus 1 and 8 plus 2. 107 degrees equals the measure of RT. Let's try the next one. Let's try part B. And of course, at any time, you can just skip forward through the video to find where it is that we talk about whatever's next. So here, let's go to the next one. Now, in the next one, part B, we're going to determine the measure of CD. So I'm going to make that visible. Cool, there it is. And what we know from our theorems so far, for example, like exterior angles theorem, and linear pair is that like this angle and this angle, they're both the same and they're both 100 because 100 plus 80 makes 180. CED, the measure of angle CED is going to be half of the sum. So plus, it's half of the sum of the unknown angle or the intercepted arc measure here and this end of the chords that cross. So I know 100 degrees as that CED measurement will be 1/2 times x plus 88. We're on the interior, so we use addition. Over here with the exterior, we use subtraction. Okay, so multiplying by 2 gives me 200. And then that means the 1/2 is canceled and the 100 has been multiplied by 2. And I'm left with x plus 88. Subtracting 88 from both sides will help isolate x. X is length. So whatever I get from my number here is going to be the arc length CD. 200 minus 88, well, it's around 120. In fact, it's 122 degrees. That is the measure of arc CD. Now let's go to the fourth question, or the third question in our 4-part series. This is for C, and we're using our resources to figure out the measure of angle TCX. So TCX is this angle. The information that we know is that angle TSX, so this one, is 17 degrees. And STW, this angle is 50 degrees. Now, there's a couple of ways to approach this. First of all, because we have a triangle in this little space, this triangle right here should add up to 180. So if I add 50 and 17 and this angle right here, I'm going to get 180. But this angle on the exterior angle on the inside would also equal 180. So therefore, 50 plus 17 is going to be the two remote interior angles that we add together, and they will add up to make the outside. Add them, get 67 degrees, 67 degrees. That's going to be our measure of angle TCX. Exterior angles of a triangle theorem, especially when we have it drawn like this. Okay, now the last one of this page. Determine the measure of MEXT, M-E-X-T. And the only information that we definitely know for sure is that the measure of angle RET is 40. So 40 goes right there. By the way, because inscribed angles are half of the intercepted arc, this is going to be 80. We're going to double it. And then all of this outside edge of the circle is half of a circle. Since ER is the diameter, all of this is half a circle. We have 180 degrees on the outside, which technically means 180 plus 80. All of this exterior is added together. And if we want to know the measure of this angle, we need to do one more thing. So we're going to have 180 plus 80. I'm going to highlight it orange, I guess. Time to bring in a new color. All of the orange arc is arc addition to make 260. Now, if it's a circle, the orange arc and the green arc that I'm drawing right here, they should add up to 360. So if this is 260, then this one has to be 100 degrees so that those two arcs add to 300. The formula or the process for the exterior angles of a circle says that we are going to say angle MEXT, E-X-T, it's this one, is half of the difference of these two, 260 minus 100, which means half of 160, which means 80 degrees. The measure of angle MEXT, I say MEXT, measure of angle EXT is 80. You guys, that is it for Activity 5, page 378. Thank you for watching. Thank you for practicing. Make sure you get your Mathia work done and any other practice along the way, and stick around for more math videos and math hints. We do have 2 more videos for this entire topic to be done, so please go ahead and click forward on those, and I will see you in the next video.